All right, well, let's get rolling. We're a couple minutes after. I put in the chat. If you're new or you haven't been for a while, feel free to drop your contact info, what you do so people can reach out to you. It's really a collaborative effort, and so we need to know who we're collaborating with, right? That being said, let's roll to the next slide. Well, let me see if I can read that. Okay, here's our antitrust statement. The Advanced Water Heating Initiative is a member-supported collaborative of professionals from across the United States. Our diverse membership includes numerous competitors, and care must be taken to scrupulously abide by federal and state antitrust laws. Members should remember that antitrust compliance is important at all times. At this and other AWHI meetings, participants should not discuss competitive pricing, profitability, allocating markets or customers, or promoting a particular product or accessory. So thank you, and glad you're here. Today, we're really excited about a couple things. One, we're going to hear about some demonstrations of the LARS project, and then also a load shift study report, which I forgot that we had read some time ago. So I'm really excited to be refreshed on that again. That being said, let's roll over. I already mentioned that, so thank you, but please announce yourself online if you want to come off mic. We'll give it a couple seconds. I'll count to 10. That's usually the amount of time that we should wait. Okay, that was 10 in my head. Joe, do you have any announcements you'd like to make or know of?
Sure, yeah, a couple announcements, and anyone on the AWHI team, feel free to jump in. Yes, and know a couple slides are for you. And then we'll get over to our main presenters today. As always, we've got some exciting webinars on deck. We're doing a combi washer and heat pump dryer webinar, adjacent technology to heat pump water heaters. You can register there. There's a live link, and then a microgrids webinar in mid-August. So check those out. Those are both live links. We wanted to highlight a couple new resources from AWHI. We produced a fact sheet and blog post that we sent an email about this week, talking about the history of heat pump water heaters. How did this great technology get all started? It's riveting, folks. It's really great. A lot of things I didn't know. Some near-death moments in the 80s, but the technology coming back. So check it out, read those. And then also we launched a new video cast and podcast, Heat Pumps and Cardigans. Fun way to chat about heat pumps is wearing cardigans. And it's going to be deep dive interviews with manufacturers talking about their technology. We do this on working groups a lot, but this gives us an opportunity to go longer. 90 minutes we spent, well, actually we edited it to 80 minutes with GE and their new residential heat pump water heater. So there's an article there and a video cast. Check them out. We are going to be doing conversations with commercial heat pump water heater manufacturers as well, coming up very soon. I just wanted to announce the Heat Pump Water Heater Day 2025 is in full swing. It's going to be October 23rd. The top link is there to register. Make sure to check it out. Going to be, as usual, this will be our 4th annual Heat Pump Water Heater Day. Tons of content on both residential and commercial heat pump water heaters. Lots of messaging to get the word out, amplify heat pump water heaters. Make sure you're part of that. Everything's free, so just sign up there on the top. Let us know if you're interested in sponsorship opportunities. And a big thanks to our sponsors already. And we announced Jigger Shaw will be the keynote, formerly with the DOE Loans Office and a big influencer. So really excited to have him as keynote. And then one more slide for me.
Joe, before you go, was that virtual?
Yeah.
Is that going to be virtual?
Yeah, okay, thanks for that. It's an all-day virtual conference, Heat Pump Water today, and it's actually there's a lot of content, so we're actually going to do a couple days before the 23rd. We're going to have different, including a food service webinar and central heat pump water heaters. And then I'll just let folks know a little sneak peek. We're going to do a live installer training event in San Jose on the day before Heat Pump Water Heater Day with PG&E. Pretty exciting. Expecting 150 to 200 installers, both residential and commercial heat pump water heaters, and we're going to live stream it to the web so you can check it out if you're not local. A lot more information coming on that. But yeah, separate. Most of it will be virtual, but we will have one live in-person event. And if you want to throw your own heat pump water heater party, we welcome that, and we will promote it. So let us know. And then one more slide for me. I don't know if folks saw, but I wanted to highlight here. There's a live link on the bottom to Canary Media. Federal court upheld air quality regulations in the South Coast. These were challenged regulations for zero NOx emission requirements from the South Coast Air Quality District. And these were not for residential heat pump water heaters. Those failed just recently, but for boilers, steam generators, process heaters, residential pool heaters, and tankless water heaters. So commercial water heaters will be affected by this, and maybe an opportunity for commercial heat pump water heaters to gain a stronger foothold in the South Coast Air Quality District, which is a lot of Southern California. It's estimated that these rules will reduce NOx pollution by 5.6 tons per day, which is the same as halving the smog-forming emissions from cars in the region. So a big victory for clean air. Check that out in more detail there. Not linked. Okay, Noah, over to you for a couple updates. And John Heller, see you on camera. Feel free to jump in on any of these.
Awesome. Thanks, Joe. Yeah, so just a couple quick updates here on our small commercial study. We have a couple of grocery stores participating in San Diego. It's a couple of Kroger sites, and the M&V installs are going to be happening in August. Just for context, for those who don't know about this project too much, we're going to be monitoring about 30 heat pump water heaters in small commercial applications throughout California and the Pacific Northwest. So these are two of those newer sites. We'll also be installing monitoring verification at a church and a restaurant in Sacramento in August too. So lots of upcoming installs and a lot of cool data flowing in on the performance of these systems. And we also have 10 or so sites identified in the Northwest. So a lot of great recruitment going on. Kudos to Ecotope for recruitment help and all the installs as well. So I'm excited in a future AWHI working group call to present on some of the data we have from Ecotope's great dashboarding app. Next slide. And then just a bit of an update on a really exciting IntelliHot IE1 installation in Chicago. You can see on the left-hand side here, the original gas units that were in place. Those ended up, one failed and one was on the verge of failing. So you can see in this middle picture here, they were stripped out and cement pedestals were put in. And then on the final picture there, those are the 4 IntelliHot IE1 tankless heat pump water heater systems that were put into place. They, instead of using a traditional hot water storage, they actually use a glycol mix to basically store thermal energy at very high temperatures and provide quote unquote instantaneous hot water through the heat pump water heater system. In addition to the 4 heat pump water heaters pictured here on the right, there is also a tankless IntelliHot gas backup system. So it's a very cool dual fuel setup here where hopefully gas is going to be of extremely limited use. The reason we opted for a gas backup here instead of electric resistance, like a commonly used swing tank, is that the electrical upgrades going up several hundred amps of capacity or even more, I think it was 600 to 1200 amps, is what would have been needed. If we didn't opt for a gas backup, it would have been $100,000 roughly just for the service upgrade. So this was a huge money-saving opportunity. It does keep gas in there, but it dramatically reduces costs, and gas is kind of a last resort in the event of a failure or in extremely cold temperatures. You can also see that it's installed in a bit of a buffer zone there, so there have been some cool engineering applications for ensuring there's enough airflow in the space. John, if you want to add anything, feel free.
No, I think that's great. You covered it. The initial design was to eliminate all of the gas usage, and the bids that were coming in to do that were making it so that the project was not going to happen. And so we were able to find an alternative to reduce the amount of, or eliminate the electric resistance backup that IntelliHot was planning on including in their equipment, to reduce the electrical demand way down to more closer to what we think is going to be a typical peak load rather than the potential peak load that the engineers wanted to design for, and that we have enough gas backup to handle those potential high days that will likely only happen once or twice a year, if at all.
Awesome. Thanks, John. And last note to add here, in addition to having electric resistance backup in the initial spec, each heat pump water heater itself was going to have 12 kilowatts of resistance elements. And the IE1 actually comes in a variety of flavors, meaning you can have backup resistance or you cannot, and different sizes of backup. So we went with a 0 backup element for these. So they're compressor only, basically. So maximum efficiency here and minimal electric resistance use. Yeah, I mean.
Oh, this is awesome. Learning so much. Thank you. I had a question on the 12 kW electric resistance. Is that at 240 volts or 208 volts? Does the unit provide different resistance values based on the rating, I guess, or what's used in the facility?
John, do you happen to have an answer there?
I can't remember. That's a good question. Yeah, I can't remember if that's at 12 kW at 240 or 208.
Yeah, it'll probably, I don't think it's our unit, but likely if it's going to 208, it'll derate to that amount.
Yeah.
So the 12 kW is probably at 240.
Probably the nominal at 240. That's probably right.
Awesome. Yeah, I think there's a 0, 6, and 12 kW options, and we want the 0 here. Cool. All right. Thanks,
And
John.
again, that was to make it so we didn't have to do any electrical upgrades and could actually afford to do the project.
Exactly. Yeah, and stay on the existing service.
Thanks. Now back over to you, Kashmira.
Thank you, Joe. Well, I think we're kicking off next. Is this, if I flip the title around, is it Made in America Grid-Enabled Commercial Heat Pump Water Heater Systems by chance?
Grid integrated.
They are.
Oh, close. AKA also known as MAGIC, acronym Award of the Year. We're going to learn a little bit about some installations of large systems, I believe, both in California and New York, pursuant to, in part, maybe, is it pursuant to that project or separate from? John?
Separate from the one that we just looked at. Is that what you're saying?
Is this part of the MAGIC demonstration, these
yes.
two studies? Thank
Correct.
you.
Correct.
The New York one won't be, though, right?
The California one.
Yep, the California one, exactly.
Okay, thank you for the clarification. So now that we've got our notes straight, I'm just going to introduce it again. So as part of, in part of a MAGIC proposal, which is part of DOE funded project, in addition to some work going on with the energy affordability, we have some demonstrations of some large ether projects, both in California and New York. So with that, maybe let's kick into it and start hearing what's going on. And then we'll be wrapping it up with the load shift study. So thank you.
Over to you, Heather. Thanks.
All right, great. Hello, everyone. My name is Heather Nolen. I am with the Association for Energy Affordability. And just to clarify, this project that we're talking about, my project, was not part of the MAGIC program that you were just talking about. We're a separate study, but happy to be here to share our experience with the eTherm. All right, so I did just test out taking control of the screen. Did everybody just advance to the next slide? All right, great. Yes. So quick overview of AEA, Association for Energy Affordability. We are dedicated to achieving energy efficiency in new and existing buildings in order to foster and maintain affordable and healthy housing for communities, especially those in the low income. We are engaged in a broad range of educational, technical areas, construction management activities, and services that promote our mission and develop the industry through R&D, through advances in technologies, and anything that can help kind of sustain these buildings that we're working with. We started in the early 1990s, providing training, doing some program design and implementation services. And one of our largest programs is we are a technical service provider and a direct subrecipient for the Weatherization Assistance Program, the WAP program in New York State. So one of our WAP projects is 850 Bryant. This building is located in the Bronx, the northernmost borough of New York City. In the Bronx, it's located in a neighborhood called Hunts Point. This is a low-income building. They were eligible for the Weatherization Assistance Program. A few little kind of about me facts about 850 Bryant. This is an older building. It's pre-war. It's a mid-rise building, has 48 apartment units in it. The existing heating system has a hot water distribution, and the electric metering is direct. So what did we do at this building? The building is still undergoing, actually, the Weatherization Assistance Program, the WAP scope of work, and that includes low flow devices for water fixtures. All lighting has been upgraded to LEDs with appropriate controls. We replaced the windows, the double hung windows, with a UPVC tilt out window, and we're upgrading the ventilation system to meet ASHRAE 62.2. On top of the standard kind of weatherization scope of work, which is a great base for improving energy efficiency, reducing energy usage at the building, kind of the base step for decarbonization, we were able to go beyond that with an electrification scope of work. And this is a pretty deep scope of work that we implemented in 2 phases. So part 1 is what we'll highlight today. That was the heat pump for domestic hot water, where we worked with Lars. The second portion of that is actually getting under contract and will be installing this fall, and that is a heat pump for space heating, and it'll include an upgrade to the existing hot water radiators in the apartments to include low temperature radiator panels. So first, just to highlight what we're doing on the space heating side, we're going to be installing 3 of these AirMax. These are air-cooled reversible module heat pumps. And then you can see a little picture here too. I don't know if my mouse is moving on the screen for you all, but this is the low temp radiator panel that we're going to be putting in. If you can see the little mock-up in the background picture there, we have a standard baseboard, you know, the hot water baseboard at the bottom of that mock-up where the red arrow is pointing, and then the 2 samples that the green arrow is pointing to. These are 2 low temp radiator panels. So we're going to leave that existing hot water baseboard in place. We are going to tap off of that, and in the bathrooms, we're putting this nice towel warmer. And then in all other spaces in the apartments, we're going to be putting these low temp radiator panels, you know, this second one right here, and then tapping right back into that existing distribution network. This will allow us to drop that circulating temperature of the hot water loop significantly and take the benefits of generating that kind of low temp, warm water distribution from the AirMax that are going to be installed on the roof this fall. Okay. But to get into why we're here, you know, the highlight of what we want to talk about is the domestic hot water electrification at this property. And it was really fun earlier because I heard you say, you know, something about throwing a party for heat pumps, and we did. I do want to, you know, give a shout out here. I see John Brody on the line, and I'm sorry you weren't able to join us here for this party, but we've got John's colleague, Kevin Gauthier here. This is Kevin on the right-hand side. And then we have Greg Rath from Rath Associates on the left. He is our local rep. And it was really through the help of working with Rath Associates and working directly with Lars that we were able to, you know, find this perfect fit for this piece of equipment at this building and make this project happen. We did throw a big party at it because it was meaningful to us, to Lars, and to the building and the owner. 850 Bryant is part of a larger portfolio of affordable housing in this area of the Bronx. The owner is really mission driven to serve the community. In addition to low income housing buildings, they also have a number of shelters in their portfolio, and they invest a lot in the community. Going beyond, providing for those direct services to the residents, they are also interested in making investments in their buildings that serve the building's best interest for the long term. And that is, the investments like the UPVC windows that they put in, making sure their entire portfolio participates in the WAP program, and looking for ways to decarb the building, to get off oil, get off gas. And this electrification project just kind of, really highlights one of those areas. And we're really excited that we were able to get we weren't the first unit off the line. John Brody can correct me on what number we are. I think we're about 5, but we were the first one installed and running. And so that's what we're able to celebrate here. So, how do we celebrate? Well, of course, the big ribbon cutting, confetti cannons, and there was some champagne. This project was made possible because we had funding from a lot of entities. So highlighted in this kind of backdrop and the folks in this picture, our main funders, of course, the Weatherization Assistance Program. Our local entity is HCR. It's New York State Homes and Community Renewal. We also wrote a grant and were awarded funds from, in partnering with Enterprise Community Partners, we were able to get a DOE grant for enhancement and innovation. So that project was, do that base WAP scope of work and then go beyond WAP, go beyond that weatherization program to do electrification. Right now, electrification is not one of the approved measures under the Weatherization Assistance Program. So we're able to use the funds from Enterprise to kind of go above and beyond that and be able to help afford this electrification program. And then we, of course, needed a bit more money too. So we're able to use HEAP funds for this project. And HEAP stands for the Home Energy Assistance Program. Again, and it was another grant that we wrote to get funds for this project. So, just to make the domestic hot water project happen, we did weatherization first and then used those 2 funding sources to make it happen. In order to do that last part of the project that I was talking about for the heat pump for space heating, we've brought in yet 2 to 3 more funding sources to make that project happen as well. Some other folks that we want to highlight in this picture is the owner. I gave you like a brief overview of the owner, but the owner played a large role in, advocating for this project and really being, willing and interested to take this step and take the leap and be the first, entity with this new piece of equipment, in the country. And it's definitely like record breaking for the South Bronx and the area that they're in. So we're excited that they're willing to invest so much in their building and kind of pilot this technology with us. Here's a shot of our team along with Greg Rath from Rath Associates, our local rep again. So that is the unit outside. We are able to, this is a 48 unit building. So we're able to serve the entire domestic hot water load with just that one unit. We did increase storage capacity inside. When we were first speccing this project, we had thought about using 2 outdoor units, but we were able to do, a combination of storage inside and sizing of the outdoor unit to go with 1 outdoor unit and then, adequate sizing or adequate storage inside. To be able to pick up 100% of that domestic hot water load. Currently, we do have the gas-fired boiler still tied into the controls. If needed, it can come online. But soon, we will have the heat pump water heater replacing that space heating boiler. And after going through this past winter, we're confident that we'll be able to use the Lars E-Therm to meet 100% of the load moving forward for this project. Here are just a quick overview of, the specs of this building, of, how we were able to to kind of wire and plumb this project. One thing that worked out really nicely with this project is we did not have to upgrade the electrical service to the building to meet the domestic hot water load. So that worked out really nicely for us. This building also has, which is really odd for New York City to hear this, but a really sizable empty mechanical room. So we had space. We were able to put in 4 of these 200-gallon each storage tanks. And we have, nice space inside, close proximity to the outside. We're able to site this unit and tie it in. So really like spacing and configuration really worked in our favor here. It's rare, I think, that we find like an open space in a mechanical room, but we were able to really take advantage of it in this situation here. I wanted to just kind of take a step back to say, why are we doing electrification? Because this project just represents like the beginning of a sample for us. We've done a couple other, or actually a few dozen other electrification projects using different technologies, either for domestic hot water or for space heating. And we're continuing to pilot some other technologies across portfolios we're partnering with. But I guess, why? In New York City, we currently have a pretty big push to electrify. New York City is looking at reducing our fossil fuel usage. So that is like how much oil and gas we're burning. New York City also has some district steam that is, produced with gas. So we're looking to reduce all of that usage and increase the amount of electricity that we're using, because the electric grid can get cleaner. Of course, the fossil fuel grid is not getting any cleaner. So we're doing what we can to electrify buildings and just overall reduce energy consumption across these properties and in the portfolios that we're working with. And this is for, improving indoor air quality, improving the energy efficiency of buildings, increasing their sustainability, and also aligning with New York City's Local Law 97, which is a mandate to reduce your carbon emissions in your buildings. And each building has, there's a whole requirement around, thresholds and an accounting calculation for how much carbon each building can emit. It's based on characteristics about your building, looking at your size, your building type. So this building is affordable rate, 850 Bryant. So there were certain, conditions for this building. But the owner was really forward thinking and said, we want to jump on board. We believe in this. This is part of our mission. And they were looking to reduce how much fossil fuels they were burning on site. And we're interested in this conversion. Here's just an idea of like what's happening citywide. It's, reducing our emissions on the fuel side, moving to electrification. And when the city talks about Local Law 97, they're really aggregating all the emissions that a building has, your oil, your gas, your district steam, and the emissions from electricity, to look at what your total emissions are, and then to say, hey, are you over that cap? I kind of use like a limbo stick in my mind when talking to clients. You need to make sure that you're under that limbo stick. Otherwise, you need to do what you can to reduce your emissions to get below that. Otherwise, there are financial penalties that buildings will face when they're looking at their emissions limit. So it was nice to work with an owner that was pretty forward thinking and interested in kind of taking the steps to reduce their carbon emissions today. I believe that is my last slide. I can pause here if there are any questions. Please tell me if there's something I missed in this quick overview of this project.
What an awesome project.
Oh, sorry, go ahead.
I was just going to say, what a great project, Heather. Thank you for sharing.
Yeah. Does anybody want to know how much this project cost?
Absolutely.
It was just for just the domestic hot water install, everything that went into that. We're kind of coming in around $12,500 per apartment.
Good to know.
That's what I've heard for New York. Yep. Crazy expensive, but hopefully it'll come down eventually.
Right. Yeah. Even after this project, we think it's going to come down, but the first one is always a little bit more.
Could I ask about the character of the owner? Is the owner a large commercial real estate institution? Is it like a one-off owner? Like what's their situation?
Sure. I think they have a decent sized portfolio. It's a nonprofit, family operated, you know, owner developer. They mostly are long-term holds. They're not producing too much on the new construction side. They're maintaining buildings.
And the building is subsidized, market rate, or mixed rate?
It's 100% affordable housing.
Very good. Thank you.
Yep. Mm-hmm.
I mean,
Any other questions?
oh yeah, Kashmir, you can call on folks.
Hi, Heather. That was great. Great to see those units out there. Any are you all doing monitoring? Is there any monitoring data that you could share with us?
We don't have any data yet. We are doing some monitoring. We're still kind of getting everything set up and collecting information. We did switch on and off between like the gas boiler and the heat pump a little bit here and there. So our good performance year is still being collected. So yeah, at this point, we're not reporting out on any performance data. Yeah, but I believe your next presenter is going to get into more of the weeds on that side of things with their California project.
Okay, Zoe and Jeff, and then Sepida.
Yeah, thanks. I was just curious how Local Law 97 might have contributed to doing this project, or whether it contributed at all.
Yeah, I mean, Local Law 97 is definitely a reason why we're doing so much research in this area and working with our manufacturers, working with, distributors to learn more about these technologies, to see where it's a good fit to pilot them in different types of buildings with different configurations. And there are different, incentive programs and research projects to study these right now. Local Law 97 holistically is a driver citywide. But when we look specifically at 850 Bryant, because they're an affordable rate property, they are eligible for what's called, there's multiple pathways for compliance to this local law. And so because of their affordability status, they do not have to do the performance pathway. They're eligible for a prescriptive pathway. And a prescriptive pathway is kind of like a checklist of items that you must have installed or functioning properly at your building. So this building, according to Local Law 97, did not have to electrify, space heating or domestic hot water. They also didn't have a specific target that they had to drop their emissions by. They could have been in compliance simply by doing the prescriptive list. But taking, kind of the reasoning behind Local Law 97, the greater part of understanding what your building's carbon emissions are and how your building contributes to the local air quality, to the emissions of New York City, to how buildings use energy, what pieces of equipment are you replacing and installing in your building that are going to be part of your building for the next, 20 to 30 years. And this owner wanted to, make those investments into electrification, didn't want to stay tied to the fossil fuel grid. So definitely a motivator, but it's different when you're talking about a market rate building that is facing $100,000 penalty on an annual basis from the city if they don't get their emissions down.
Yeah, for sure.
Yeah.
Okay, thank you.
Mhm.
That was a helpful response.
Awesome. Jeff.
Thanks. Great presentation, Heather. Thank you. I had put a note in here. I'm just curious, what is your EM&V effort and what's that going to cost? And what would have to be added to the machine or what was already included?
Sorry, did you say what your M&V costs are?
EM&V, yeah. I mean, and you're, I assume, monitoring for probably a year. Is that about right?
Yeah, we're probably going to, keep monitoring it. If this building happens to just be like a mile or half a mile from our office in the Bronx. So we're going to be keeping tabs on this building. Plus, we're doing a lot more at this building by installing the space heat pump this winter. I don't have the details on what our M&V plan is for this building. We could follow up on it if you're curious, but yeah, it's still underway.
Okay, and I'd be curious how many points you're trying to get, and was that included with the equipment or was it something that had to be added later?
I believe we're adding it on later, but
Great, thank you.
Sepida.
Yeah, thank you, Heather. Sorry, first of all, my camera doesn't work. I can't come on screen, but it was lovely to see the presentation. Curious, you mentioned that you have the original gas water heater still there and that you plan on removing it based on the data that you've seen so far. Did I hear that correctly?
Right, we will be.
And I'm curious if it's not really turning on, would there be an opportunity or a benefit of keeping it there from a resiliency perspective in case of outage and so forth?
It's something that I think our team is looking into, where we have the air max that are going to be on site to provide the space heating, and we're looking at doing all the tie-ins for that. It's also a situation where the current existing, it's just a hot water plant. It's not dedicated domestic hot water heaters. We just have, a couple of boilers providing space heating and domestic hot water. With that equipment approaching end of useful life. So the owner isn't going to be investing in keeping that equipment online or replacing that equipment, that gas equipment.
Got it. Okay, thank you.
Yeah.
Okay, any other? Oh, Vish.
Yeah, one last question. Thanks for the presentation. Have you looked into the delivery water temperatures? Because, boilers output very high outlet water temperatures, whereas the heat pumps provide less. So how are you going to tackle that heat load management? And also, because these are like not instantaneous water heaters, right? So these require high flow rates or lower flow rates in order to reach those higher temperatures. So have you considered any of these options, or like as a backup, it's beneficial to have a gas or even a tankless as a backup? I don't know if that makes sense.
Yeah, it's definitely things that our team looked into, when committing to this design, working with Lars on this design, making sure the owner was comfortable with what we implemented. Omar from Ecotope might be able to get into the technical side of this a bit more. Our engineer who designed this project wasn't able to join the call today, so I'm not going to be able to adequately answer your question. But we did think about those options, and we didn't feel it was necessary, and it's not part of the design. We're not going to have an electric backup, domestic hot water tank here. We did increase the size of the storage to help with the temperatures and to be able to provide adequate temperature. And that played a lot into the design, is the increasing of the storage capacity. But yeah, without our design engineer of this project here, I won't be able to get into the weeds of that. But if you wanted to reach out to me, I can put you in touch and we can follow up on that offline. And Omar, your next presenter, he might be getting more into the weeds on that technical side.
And maybe we flip over to the next slide so they can see your contact info.
Yes, here I am. Please reach out with questions.
Thank you, Heather. And definitely, as you get more information on the M&B, could you just shoot it over to MBI so they can distribute it to other parties that might be interested?
Yes, we definitely will be, publishing a few case studies, once we have that information, and we'll make sure that you guys get it.
Thank you, Heather. Okay, no more questions. We're all good? Great. Well, with that, let's run over to Omar and have him share his current experiences in the Lars demonstration in California.
Awesome.
Omar, can you
yeah, if you want to
introduce
just take
yourself?
control, you should be able to navigate the slides.
Yeah. So can everyone hear me?
And indeed.
Yes.
Good. Well, hello. I'm Omar with Ecotope. I first want to start by kind of piggybacking off of Vish's question here. I think Heather did a good job explaining that you usually go about it by having a decent amount of storage to deliver the hot water that you need. And typically, like these heat pumps, we'll look into it in a bit. can provide up to 180-degree water. In our design, it's only providing 160-degree water, and the storage tanks can maintain 160-degree water. We have 1,000 gallons of storage for about 88-unit multifamily building, and then it has a swing tank to take care of the recirc load, and it's mixed down at the mixing valve to provide 120, 125-degree water to the building. This demonstration project in Sacramento, California, does have an electric instantaneous backup, but it's not for sizing concerns. It's for emergency backup. So with that, I'll get started. This has been a really interesting project. We actually got to do the start of commissioning last month. So I'll be sharing a little bit of that and focusing conversation mostly around load shifting. So a little bit of talk about the agenda I'll be talking over today. The large demonstration project in Sacramento, it's replacing a gas boiler system. They had 3 gas water heaters, and it's utilizing the first US-made CO2 heat pump capable of shifting load for the grid, which is great. So we'll be starting with talking a little bit about the technology innovation model, then introduction to the building, looking at some plans and pictures. We'll talk about the equipment and how the demonstration was set up, and followed by some testing results that we did in our commissioning test. And finally, what the data looks like via Ecotope, which is our M&V monitoring platform. So this is our technology innovation model. It was developed between BPA. I need to be going back, not forward. There we go. Developed between BPA and Ecotope. And its goal is to study new technologies and bring them to market. Every idea starts as a feasibility paper to study the product and determines the application. The analogy we like to use is that if the heat pump water heater, for example, is the engine, then we explore what kind of cars it will work with. Then it goes into applications testing, and that's like testing the engine in a few different cars based on what we know, before actually setting it out in the world and proving that it works. The next step is a real world demonstration project with M&V equipped, where we collect measurement and verification data and continue the cycle and optimizing the system's design and controls until it's ready for market. And this is a step that the Large Ether is currently at. Now, looking at these site plans, these are enlarged plans for the outdoor. I'll show some pictures in a minute, but this is an outdoor skid. This is the heat pump, and these are 2 500-gallon storage tanks. And to the right here is the mechanical room. You'll see that those 2 lines, they go through like a small fire pump room and then actually hit the mechanical room, where we have our expansion tank, we have our swing tank, and those are the 2 instantaneous electric backup heaters I was talking about. And my favorite part, the central controller, or the brains for the system. Let's take a look at the schematic. So this is inside the mechanical room. You'll see on the left here, that's the heat pump. This is all outside. You have your hot water line, cold water line going to the 2 storage tanks, 500 gallons each. And if we have your hot water coming up at the top, cold water coming into the bottom of the 2 tanks. If you follow the cold water line through the bottom, it hits the input for both of the electric backup heaters, which can be bypassed or are bypassed, expansion tank, and cold water from the city, where we have our flow meter. And coming off the top of the 2 tanks, we have our hot water also hitting the output of the 2 electric backup heaters, going into the swing tank, out of the swing tank, and into the hot side of the mixing valve. You'll notice that the cold water line is mixing with the return water coming into the cold side of the mixing valve and out to the building. Here are some before pictures. This is what they had in the mechanical room. Those are the 3 gas boilers. And this is the outside. Looks like it's got like 2.5 parking spots there. And here's the after. It's kind of hard to get the same picture inside the calc room because I did want to show like the central controller here. Those are the two electric backup heaters. You have your mixing valve there, recirc pump there. That's a swing tank and expansion tank. This is an existing booster pump, which we saw here, that remained as is, and its hydropneumatic tank in the back there. And this is the after, which I'd say looks pretty sweet. This is now all fenced off, and there's a sound attenuation thing on the top of the heat pump here. So moving on, see if there's any data here I didn't talk about. So the Lars E-therm uses CO2 or R744, global warming potential of 1. It can deliver up to 180. We've only decided to 160. Its capacity of 325 MVH, about 95 kW. And we do have the MVB package. The best part about it is that it is a fully packaged system. It comes with a controller. The load shift capability is pre-programmed from Lars, and it's great to use. So I want to talk a little bit about the standardized controls. So the design and controls were aligned with the NIA Advanced Water Heating Spec Appendix H and the utility requirements. In this case, the utility is SMUD, and they qualify for the load shift incentives there, and they also qualify for the California tech incentives for heat pump water heating systems in multifamily buildings utilizing load shift, which is great for the Lars system because it has load shift capability built into the central controller, which was great for us to go test and set up, and allows the system testing to be really easy. It took us about half a day to do the load shift testing, and it's great to have it all standardized to provide accurate, reliable, and consistent savings. Once the power meters are set up on site in the next couple of weeks, we'll be able to calculate the system COP using both the boundary method and equipment method from the Advanced Water Heating Spec. We do want to compare those, and it should be automatically calculated on EcoDash, our monitoring platform. And you can actually access all three of the configurations through those QR codes on the slide there, if you want to take a look at them. And the really cool part about it, which I've been messing around with, is that we're also able to remotely access the central controller, like from our office, which is super convenient. Like you can adjust set points, you can change like the load shift schedule here to whatever you want it to be, you switch out the phases, change any of these set points, which is great. I do have some more controller pictures here. The one on the left is when I was watching the system perform during the load up phase, and the picture on the right is when we manually shut off the heat pump, and we're testing the two backup heaters, which is why you'll notice there's an error telling us that the heat pump is down. But that was on purpose. Which brings us to results. So these are the results of the load shift portion of our startup commissioning testing we did last month, which is based on NIA's metrics for quantifying load shift. The first table shows the system COP and is drawn from the qualified products list straight from NIA's website for the system. I do want to cover, hopefully really quickly, 3 definitions before diving into the second table, which are these 3 columns here. The first is thermal shift capacity, which is the hot water energy released between load up, when the heat pump turns off, right before peak demand time usually, and shed, when the heat pump turns back on. It's basically a proxy for how much energy can be shifted away from peak periods while meeting domestic hot water demand during those peak periods. The second is electrical shed capacity. And this is the electrical energy that the system could shift between load up and shed. And it's basically energy that you have divided by the COP in summer or winter, which is why you see 2 there and in the first table. The third is peak load reduction, which is simply the amount of electrical power the heat pump water heater would have pulled during the utility's peak demand window if we hadn't pre-charged the tank and turned the unit off. It's the kilowatts we kept off the grid by shifting the heat pump water operation outside of those peak demand hours. So here you can see in the first row, this is our theoretical ecosizer, utilizing the ecosizer engine. This is what we estimated what we should see, and this is our real world testing, which resulted in thermal capacity that we could shift came in just above about 94% of what we estimated, which was really cool to see. And now to talk about EcoDash. Like I mentioned, it is the monitoring dashboard where it's set up and connected to a database, which has new data automatically populated each night. Once the data is in the database, it's visible on EcoDash and anyone can access it. The summary plots shown are automatically generated, and it shows long-term system trends. It could show a lot of things. Ideally, we'd be able to show the system COP, but we haven't gotten that yet. We're just waiting on the power meters, like I mentioned earlier, and that should be automatically populated. The top, I could talk about these a little bit. That shows your daily hot water usage. It's really convenient for like determining building occupancy. You could catch things early on if you're seeing that the performance isn't what you're expecting. You might be able to just look at a graph and see, oh, well, for whatever reason, this site building occupancy is really low, so our efficiencies aren't what we're expecting. And here you can clearly see that heat pumps are a lot more efficient depending on ambient outdoor air temperatures. They're operating at more efficiently and at a higher capacity when there's more heat in the surrounding area that those heat pumps can suck out of the air and dump into the water. Here, there's another tab where we're looking at the raw data. All of this could be viewed. All of the data that we're talking about can be viewed here. We have all these toggles that can switch on and off. And it's really helpful for digging into any issues that you would have identified from looking at the summary data if you need a closer look, and figuring out any necessary actions to fix them. Oftentimes, take screenshots from this, share with people on site or with the manufacturer, and kind of determine what solutions might need to be explored or what would need a little bit more digging. And that's our presentation. Hopefully that was clear and hopefully that was clear and you're able to follow along, and we can open it up for some questions.
Thanks, Omer. Yeah, that was great. Love the visuals, and always cool to see the huge change in COP depending on dry bulb temp.
Yes.
Interesting to see it get damn near as high as 4 and all the way down to about 0.5 as well. I didn't even think about that for the Sacramento region having that much of a swing, right? Since it's fairly temperate, besides being warm in the summer.
Yeah. I did see like some messages coming into the chat, but I wasn't able to look at the questions. I assume we can either look at those or people can raise their hand and ask. I do have like Tristan Scott has his hand raised here. It looks like he's going through some. Yeah.
Go for it, Tristan.
Hey, everybody. Yeah, thanks for the presentation. Very exciting. So you mentioned load shifting with SMUD, and I have a couple of questions. So the first one is it set on a schedule and then you have to remote into the control panel that you showed to set it to a different schedule? Or is it set to receive grid signals in some way that's automated?
I believe it's set to a schedule set by the utility. And you just input that right here into the controller, and it would just follow that. I believe that it's yeah.
Right.
Okay.
And does that mean I mean, often in California, utilities have seasonal schedules. So does that mean somebody's going to have to go in every season and change that?
You don't have to go in. You can just access it online. Takes a couple minutes for me to
that's
on
what
and
I meant.
switch it. Yeah.
Right. Okay, so who's going to be doing that? Let's say in 5 years.
So Tristan, I think I know kind of what you're getting at, and the controller can also have a CTA port plugged into it, and so this is how we set it and left it when we did commissioning, but it's there available for the utility to connect it through CT 2045 when they have a program.
Right. So there's a CTA 2045 socket somewhere on the machine.
Right. Yeah.
Okay, thanks. And then to get to the EcoDash, Scott or Omar, are you basically, is it pushing data to the EcoDash? Can you just describe briefly the communication path for the EcoDash to be involved?
Yeah, so Lars, this was a really great part about the technology innovation model and the partnership we had with Lars here, because they designed their controller to accept the inputs that are defined at the advanced water heating spec, and then there's an API that they've got that we can pull the data off the panel through that API. So it's fairly plug and play for EcoDash, because you install it, you hook up the instrumentation to the inputs that it says in the control panel's installation guide, and then you just connect it up with an API to grab the data.
Right. So the control panel means an on-site box is basically connecting to your EcoDash server, and is it doing that over some internet connection that's available? And are there different options on the internet connection? Is it always sort of an Ethernet cable or other?
Yeah, so on this site, Lars has a cellular connection built into their controller. So it's the same controller that controls the heat pump and it controls the whole system. They have an option to do it without the central controller, but if you want the load shifting and all of the monitoring, and it makes it a lot easier to use when you add the central controller. And so on this site, they had cellular added to their central controller, but you could also just plug it into the building's internet.
Okay, great. So I'm hoping that these questions are helpful for everyone. So I only have one more. So if in the next Lars installation with this control panel, would somebody be able to just basically notify Ecotope, hey, we'd like to have EcoDash involved, and then they push a button on the controller and it just sort of happens? Or do they have to call you? You have to know the IP address. I'm trying to figure out how automated it is versus.
It's the second point there that we need to
so
know.
A little bit of manual intervention.
Yeah, they need to give us like the actual address of the equipment so that we can and give us permission to grab the data through their API on that specific device. And I would say the other piece of that is whoever's designing the system would need to make sure that the flow meters, the temperature sensors, power meter, that stuff is spec'd and connected to the panel at startup. But Lars could also do that because Lars was involved in this project with us, and so they know what temperature sensors and flow meters they need and where to put them.
Great. Thank you, everyone.
Mm-hmm.
Any other questions, folks? Jeff,
Omar,
go ahead.
Omar and Scott, curious, working with SMUD, did everything that came with the unit meet their EM&B standards? That's one question. And the second question is, was or is there the possibility of an ongoing incentive if you maintain that COP, not just your first initial COP or after a single year, but over a 10-year period? Was SMUD or would SMUD have the appetite to basically say, if you can keep the COP, we will reward that over time?
So the first,
Jeff, part of this study is to help SMUD figure out what their program should look like for commercial heat pump water heaters. So they have a program currently that gives additional incentive for systems that have additional storage capacity, with the idea that that would lead to the ability to load shift.
Mm-hmm.
And what we're doing as part of this study is helping them refine those requirements and their incentive program.
Okay, thanks, John. I think it might be one of those really fun discussions to go down and say, okay, so you got this great performance. How long does that last? And oftentimes we see a decay of those things, and it's such an unfortunate thing that they shorten their life on their measure from 10, 12 years, which is where it should be, down to 3 to 6 years or something like that. Just a thought.
Yeah, and I would say that you've convinced me of that way of thinking, and our current thinking around talking to utilities about how their program should be structured is that they should really only be structured if there is the type of measurement and verification feedback and alarming capabilities that come with the type of dashboard interactivity that we're showing with the EcoDash. It doesn't have to be EcoDash, but it has to be something like that, so that and there's direct feedback and automated feedback to the owner or to their maintenance staff that the system is operating as it should be or not.
And potentially the utility. I mean, it's
potentially the utility, yeah.
It's a peaker power plant too, so it's a resource then. Thanks.
Kashmira. Okay, I'm gonna call on myself. I think it'd be worthwhile to have a session with the Advanced Water Heating Initiative to get a survey feel from folks on what they're seeing in their utility programs. So, for example, in discussions internally at Bonneville, we're looking at custom projects for central heat pump water heater systems, but we also have already in place opportunities for retrocommissioning that could be utilized to do exactly what Jeff and others have been kind of talking about. And so it might be worthwhile to use this engaged collaborative to get some feedback from others. Now, maybe we could take that as a topic for a future discussion.
Absolutely.
Count me in.
Omar, thank you. Oh, go ahead.
Kesh, this was Jeff. I was going to say, count me in. I'd love that discussion. John and I just started this conversation. Gosh, when was that? 2022? A while ago. So, yeah.
So super exciting to hear about this LARS project, and both in New York and in California. And it's great to have an American-made CO2 system. So that is a really huge accomplishment. And one other thing I realized by reference for other people is that we do have a NEO qualified products list. That was a little snippet I tried to stick into the chat that shows where these systems are. Like, for example, was it custom engineered? Its market delivery method was noted as custom engineered, not skid mounted at the time, and the product is on the qualified products list. So I just want to put a plug in for that, any chance we could get. Okay, who do we have next?
Me.
Great.
Yeah, hi everybody, Valmiki here. Joe and Kashmira, I feel like this was about the time I was supposed to be finished by the original schedule. How much time do we have for?
So I think we have 30 minutes left on the meeting, so you should be okay. Are your slides in the PowerPoint? Let me double check here.
Yeah, they're there.
Perfect. Okay, let me reshare screen then.
And Valmiki, I'm glad you were presenting. It's been a while since we've read your load shift report. I know that there's lots of people interested in load shifting, so I'm glad you're here to share it. So thank you.
Thank you, Kashmira.
Awesome, Valmiki. Yeah, this is just loading up here. Let me skip over to.
Oh, whoops! I
here.
took control. I got it.
Perfect.
All right, you all seeing the right slide?
Still seeing mine here. I can. Do you want to share separately?
I see the
see
Ask
Valmiki's.
Energy central heat pump water heater load shift testing.
Okay, I'll take that as confirmation. Thank you, everybody. Thank you, Heather and Omar, for sharing your projects. It's great work, and good job. Keep it up. Thank you for sharing, and thanks AWHI for having me back. I've said it before. I'll say it again. This is a really great group of people to be collaborating and working with and learning from. It's a highlight of my career, so much appreciated on my end. So I'm Valmiki with Ask Energy. I've been working, and we've been working on a handful of central heat pump water heater projects through the CalNext program for a few years now, and hopefully for a few years to come. CalNext is the emerging technology program for the electrical investor-owned utilities in California, and so we've been working on a number of projects on their behalf and with their blessing. So that's been a great program for us so far. One of the projects that we've been working on is load shift testing. So you're going to see some similar plots and ideas that you just saw in the previous presentation. These are close to Sacramento. These two buildings are multifamily buildings in San Francisco, so not too far away from Sacramento. This is similar to what I shared at the Hot Water Forum for in the spring for those of you who are there, but some more finalized results. So hopefully some new information. And I would encourage any of my project partners that might be online to jump in at any time. So just to set the stage a little bit, here are our two buildings. They're about 100 years old in downtown San Francisco. They're high-rise multifamily buildings for a low-income senior population, part of a nonprofit's building portfolio in the area. And these were outfitted with central heat pump water heater systems, replacing existing gas systems. What was it, in 2022, I believe? These systems use Mitsubishi's QAHVs. Each building has two QAHVs on the roof, connected to a bank of storage tanks in basement mechanical rooms. These are both swing tank configurations, and I'll show you the schematic in a minute, but they also have ample storage, both of them, more than ample storage. And then I would just kind of highlight one thing that's important about this building that's central to what I'm trying to impart here is that both these buildings not only are on time of use rates, but have demand charges. And these peak demand charges are really central to why we wanted to come back to these two buildings. Not all multifamily buildings have peak demand charges. These do, in California, that is. On the other hand, almost all commercial buildings do. So it's relevant to any building with those demand charges. Here is a schematic of one of the two buildings. They're essentially the same with some different amount of storage volume, but very similar otherwise. You have, I don't know if you can see my cursor, but yeah, anyway, here you have your two QAHV heat pump water heaters in parallel. You've got your big storage volume array here that was plumbed in sort of a combination of series and parallel. You can think of it as one big volume with coldest down here, hottest up here. So it sort of has that thermocline across in that direction. Then your swing tank up here. So this is a swing tank configuration like many of the others. And yeah, this is a CO2 refrigerant system, if I didn't mention that before. All these circled values are our measurement points. So this is what's being included in EcoDash and various measurement points and data points that you can use and have been using to evaluate the system. This is a quick summary of what we looked at in our sort of first phase of this project. We evaluated the COP. You see that sort of kind of typical relationship to outside air temperature. Good COPs, the advanced water heating specification tier 3, so pretty good COPs on average. Even better, at least in one of my sort of focuses is the greenhouse gas emission reduction. And when we compared it to gas baseline, the previous system, around 85% greenhouse gas emission reduction. So we're all, motivated by that. And then we tried to do some load shift testing in that initial phase. And we were pretty successful at moving quite a bit of the energy consumption, the KWH, out of on-peak periods, but we were not successful in lowering peak demand. So we still had the KW up as high as it would have been without load shifting. And what we found when we tried to analyze sort of the cost impacts of that load shifting that we tried, those demand impacts were really overwhelming any cost savings we were getting from shifting energy. So we wanted to return and try to figure out how we could lower those peak demands and lower that peak demand charge on the monthly billing cycle. So that's really what motivated us to return. So return we did, and this is a kind of a busy slide, but basically this table here shows the different EcoPort modes that we programmed in our return to try to test different load shift schedules and weeks over our test period. The thing I really want to highlight is that the main addition we added to the second phase was in the critical peak control mode, the EcoPort request. We added staging of the two QAHV heat pump water heaters and a lockout of the swing tank. So the idea being, the hypothesis being that we could load up during the off-peak hours or pre-peak hours, you could say, and then during the peak hours, use that staging to keep one of the heat pump water heaters off for as long as possible, and also keep the swing tank off since it's locked out, and be able to coast with what was stored, and be able to coast with only utilizing one of the heat pump water heaters to maintain our supply temp during those peak hours. The whole motivation is try to keep coincident peak demand down, since those demand charges are so impactful. Briefly through this slide before we get to some of the results of that load shift testing. One thing I like to do when doing load shift testing is to compare the hot water usage on normal and load shift days. So that's what this does. These two curves that show the load profile basically show that the hot water usage of the building, of the residents, didn't change even though we were load shifting. So that kind of confirms that there's no change in water usage. And also at the same time confirms that there was really no impact on supply temperature of the hot water to the building. So that kind of confirms that we have a fair comparison in our load shift test. And then down here in this table is a series of schedules that we tested with different lengths of load up and different lengths of shed. Mainly, again, we were focused on critical peak as a shed mechanism. To illustrate the response to our control signals, here's a few plots that kind of show the typical response, the average response over some of these different schedules that we tested over, it was about half a year or so at both sites. You can see here's our baseline. Oh, and so the purple line there is the swing tank energy consumption over a typical day in kilowatt hours per hour. And then the two others are the two different heat pumps. So you can see when we did the typical shed operation that doesn't have staging, the two heat pumps, they load up in tandem and they shed in tandem. But what this doesn't show is that these are both cycling, right? This is KWH, but if you were just looking at demand, these are cycling up and down. So our peak demand charge is still high for both of them combined. And then when we have the staging, you see that they load up together, but then once you get to the critical peak period, they separate. One of them's forced off for as long as possible. The other one maintains. And we saw at both sites that one heat pump water heater was enough for that critical peak period. There's a lot of information on this slide as well. I'll just kind of highlight some the sort of highlights for me anyway. These are our results across the different metrics for some of our different schedules. This is at one of the sites. So here's our different schedules. I kind of just want to highlight the maximum benefits, I guess you could say, we achieved. At site one, we got up to around 19% of energy cost savings as compared to not having load shifting. And again, those are really driven by the demand charges that we were able to limit. And then you compare it to you look at greenhouse gases too. I think that says 8%. My font is really small there. So pretty good return for not a whole, dramatic change to what the load shifting can do, but just doing that staging and locking out the swing tank, we got some pretty good benefits. If you ask me, 19% cost savings is pretty cool. This is site two. We weren't able to do as many schedules at this one. Here we saw 10% cost savings for one of the schedules and 12% greenhouse gas savings. So again, pretty successful if you ask me. One thing I would note is that these different metrics of beneficial impact don't always go hand in hand. So it's like there's a mismatch between some of the different metrics, including what California has called TSV, which a lot of their efficiency programs are being based on now. TSV is sort of the grid impact and societal and grid impact combined. And any one schedule doesn't seem to, or at least in this test instance, experimental instance, doesn't optimize all of these different metrics at the same time. So you kind of have to pick and choose which one is most important at this point when you're selecting which schedule to ultimately employ over the long term. Hopefully over time, those different metrics will come into alignment through rate reform and et cetera. Just some of the conclusions in our final report that I wanted to share. There's more in our final report that you could look at if you were interested. We found that load shifting was very successful at this building with these demand charges and 2 heat pumps. So this staging and this swing tank lockout worked really well. And personally, I want to kind of emphasize how important it is and necessary it is for cost-effective, equitable implementation of these systems. Not just as sort of a utility activated demand response strategy, but as a kind of a standard everyday operation. Load shift is important in these time of use situations. There's some improvement that we could still do. We could go back and do more. You might have noticed that in the staging load shift response, one of the heat pump water heaters did tend to stay on. We could probably be a little more aggressive and in the control strategy, have them both go off probably, and then one come back on. So I think there's some room for more improvement there. And then also we weren't able to add alternating sort of lead lag of the staging position of the 2 heat pump water heaters. That's an issue for kind of evening runtime and lifetime of these products that would impact the customer. So we I think that's important for Mitsubishi and others to definitely make available. Let's see what else I wanted to mention. Kind of getting to what John and Jeff were talking about with sort of longevity of performance and efficiency of these systems, we ran into a lot of problems over time, over the length of our study over the past, what is it, almost 3 years now. And a lot of it kind of depended on temperature maintenance loads and how the swing tank reacted to those temperature maintenance loads. And so, yeah, we need to build these monitoring tools and alerts and fault detection so that we can repair those things and fix those things and keep those that system performance up. And in our particular study, temperature maintenance and swing tanks were particularly influential in that regard. So I wanted to highlight that need. And then one last point that I wanted to say is this fixed scheduling is kind of a rough implement, right? We can just choose a fixed schedule, hours of the day based on time of use rates and how the system is responding. But ultimately, these probably are going to be more algorithmic and have more inputs and outputs and float around from day to day depending on state of charge and load and utility signals. So this is an important and useful current solution, but I kind of just want to put that in people's minds that that's probably where we're going, or perhaps anyway. Yeah, so there you go. Thank you again. I want to thank my project team, Ecotope and AESC. I want to thank Skycentrics as well for helping us out, and of course the CalNext program. If you want to take a look at the reports, there's some links, and of course, if you want to reach out, I'm always open to more discussion. So thank you very much. Do we have some time for questions?
Yeah, we've got about 7 minutes left. Kristen, go ahead. And thanks so much for the great presentation. Love all the graphics, Valmiki.
Yeah, thanks a lot. I'll try and be brief. So Valmiki, all of the cost calculations that you said for savings, were those based on just sort of kilowatt hours or just time shifting calculations, but not peak demand charge management, right?
For this study, no, we calculated energy use costs based on the PG&E rate schedule and tariff, and those include both KWH and KW charges.
Right. But you only were measuring what impact the water heater had on the KW and KWH, right? You weren't able to tell, you weren't watching the meter to be able to see when it was impacting peak demand charges, right?
I understand what you're getting at, Tristan. Yeah. So another sort of factor here that you're right, we didn't measure is whole building meter energy use and KW. We assume, I think reasonably so, that the peak demand of the hot water system coincided with the whole building at some point, coincided with the whole building peak. I don't think that's again, that's over a whole month. One instantaneous peak is the basis for the whole month's demand charge. And given the time of day, I think that's a pretty safe assumption.
Right. So I just wanted to let everybody know that the Skycentric Skybox is in there, and we are now working with the owner of the building to continue to do the algorithmic, watching the weather, the performance of the water heater, and the water and the demand charges, and actually continuing to optimize that for the life of the system. So, thanks.
Thank you, Tristan.
Super cool. Valmiki, I had a question, and this might go also to your broader team. I know that our experience in demonstrations is that kind of senior housing load is not as peaky as other loads, maybe of, let's say, traditional market rate multifamily building. So how did that impact your analysis? And I don't know if you guys have kind of conferred about that, because we've got Bayview that also had load shifting, Mitsubishi QHV, and notice those flatter loads. And same thing, I think, at Elizabeth James, which was a Sanco system.
Yeah, I mean, they are home, I think, more often, but I don't have enough context to compare. If Scott or John want to comment on that, it does follow the same sort of bimodal peak, profile, though.
It does. I would say, Kashmir, that likely the savings would be higher in a market rate project because of that. We see more pronounced peaks in the morning and the afternoon or the evening in market rate because people leave and then they all come back at the same time, or they used to before the pandemic. There was very clear morning peak and evening peak that are more pronounced in a market rate worker housing than senior housing where people could have dinner at 4 o'clock.
Right. And so what made me think about that was, I think, Valmiki, you had said, you know, we want to make sure this is equitable somewhere in your presentation. And so time of use pricing is a little more challenging, I think, with this type of housing situation, multifamily housing situation, because we don't have as much time to recover between the morning peak and, you know, our evening peaks and stuff like that, because it's generally flatter because those folks are at home. So maybe that's just a point to kind of, I don't know, weave into the tapestry of design moving forward.
Yeah, I just provided a link there too to a modeling study we did that kind of touches on this, comparing different load shapes and load shift time periods.
Thanks, Scott. Other questions, comments? Great set of presenters today. Thank you, Valmiki. Thank you, Heather. Thank you, Omar. Noah, really nice job over at NBI. So I know that we have a lot of people interested and engaged, and the market is moving. So the more conversation we have, the better.
Absolutely. Thanks so much. Yeah, thanks again, presenters. And this is being recorded, and we'll have it posted on YouTube within the next week or so in case you want to share around the great presentations.
Thank you.
Cheers, y'all.
Thanks, everyone.